This is geometry 4.9b. We're going to talk about what we can do with congruent triangles again. We're going to start out by doing a little warm-up. You're going to do your own proof. There's one part that we need to change here. These angles are not going to be considered congruent. But you go ahead, make a plan on what you see and how you can write your proof. That's the most important. Can you decide what this is all going to do for you? And then we can come back and write the proof. But if you can't decide, given this information, how we're going to prove triangles congruent, then you shouldn't be able to write a proof. So go ahead, pause the video, give that proof a shot, the planning definitely a shot, and then come on back and I'll walk you through it. We know from the given information that AC is congruent to EC. That's already marked in our picture. We see that ED is perpendicular to BD. I wonder what that means. Because they're perpendicular, it tells us that D is a right angle. At least we can put a box in that corner because they're perpendicular. Now it tells us that AB is perpendicular to DB. So what is that going to do for us? We're going to create another right angle. That's what perpendicular does. It creates right angles. We know that C is the midpoint of BD. So what does C actually do? It's a midpoint. Great. What does it do? It creates two congruent segments. If you have a midpoint, then you have two congruent segments. Now it looks like we have 3 bits of information. So we have to decide, how are we going to call these triangles congruent? There are 5 ways we call triangles congruent. Side, 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 angle, side, angle, side, angle, 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 side, and RHL. Those are the 5 ways we prove triangles congruent. So which of these 5 ways would be appropriate for the information that we know? So we're going to consider the right angles to be a right, it's going to create a right triangle. We're not going to consider them congruent to each other. That's why we crossed it off here. That was incorrect. We're not going to talk about the angles being congruent. We're going to talk about the angles creating right triangles. So we're going to use RHL to prove these triangles congruent. And that would end us off. That would be what we're trying to accomplish. So let's go ahead and see what we've done. We see that AC and EC, those are across from the 90 degrees. Those are the hypotenuse. Then we're also talking about a midpoint. So we've got a lot of different things that we could talk about here. It looks like midpoint, they're suggesting to talk about it later. So we'll talk about midpoint later. What could we talk about right now? If midpoint's going to be talked about later, is there anything to discuss about perpendicular? Because of the perpendicular, we know that angle B, comma, angle D are right angles. We don't need to use 3 letters. You could use 3 letters, but because B is all by itself, there's no additional angles happening here, you wouldn't have to use 3 letters. So if perpendicular, then right angles. If 2 sides are perpendicular, then they create right angles. So on our proof sheet, if two lines are perpendicular, then they form right angles. That's the wording that we're using. I've shortened it up a little bit. I've just talked about if perpendicular, if comes earlier, then what are we talking about right now? We're talking about right angles. So what's this right triangle stuff? ABC, all right, EDC, okay, are right triangles. What do we say about right triangles? From our proof sheet, you might need to add this one in. It's about right triangles. You might add this onto your sheet. If a right angle, if a triangle has a right angle, then it is a right triangle. So you may want to add this onto your proof sheet. So why do we have right triangles? If right angles, if comes earlier, then what are we talking about right now? Right triangles. So that is giving us our R. In our plan of RHL, we've talked about the H, we've talked about the R. Now I have to come up with a way to get an L the same. I have to talk about how to get a leg the same. And that came from the midpoint. So if midpoint, then congruent segments. If a midpoint of the segment, if a midpoint divides a segment into two congruent parts, oh my goodness, I'm saying it all over the place. If a segment has a midpoint, then it divides the segment into two congruent parts. So we know that BC is going to be congruent. That's the 90 degrees down the two ticker. So we're going to go the 90 degrees down the two ticker, DC. That would be the legs of the right triangle. So now we've talked about the hypotenuse, we've talked about right triangles, and we've talked about the leg. That's the order we did it in. But when we state the reason we're using RHL. Remember, many books talk about it as just HL, hypotenuse leg. But we like to use RHL to remember it's 3 letters. We need to be sure that we prove right triangle. Congruence. All right, last one. You should realize proofs can stop at congruent triangles. Sometimes we stop there. Sometimes we go further and we talk about other corresponding parts that are congruent. That's what we did yesterday. And then today we're going to go even further and talk about what other corresponding parts are doing. So in this case, we're going to discuss how we have parallel lines. What is necessary for us to have parallel lines? What's got to happen for us to know we're going to have parallel lines? Well, that's taking this statement and working backwards. We need one of these angles to happen, to be congruent, for the lines to be parallel. If lines are parallel, then I know I have this. If I have this, then I know I have that. If I'm trying to prove lines parallel, then I'm going to need to know that I have some angles congruent. And the typical ones that we've been discussing most recently have been alternate interior. It gets a little complicated in here. Which ones are we going to talk about? Well, you got to pay attention to what we have. The information that they're giving us right now is that AB is parallel to DC. That's different than what we're trying to say. Right now, that's what we know. So if we look at that pair of parallel lines and the transversal, then that's going to tell us that angle 4 is going to be congruent to angle 2. Those are alternate interior angles. That's making a zigzag. So I know that for sure. So that's a pair of A's I know for sure. I also know a pair of S's for sure. Happens to be the same pair of sides. Just a coincidence. Parallel does not mean congruent. They have to tell us that. So now I know a pair of S's that are the same. Okay, there's no more given information. What's something I know for sure? You can't use this parallel. We haven't shown that yet. We can't use it. What do we know for sure? We see that both triangles are sharing the same reflexive side. So it looks like I have two S's and the A that is in between those two S's. So I'm going to prove them congruent by side angle side. So that's going to make my triangles congruent. Once my triangles are congruent, I know my corresponding parts are going to be congruent. That's going to make these, angle 1 and angle 3, congruent. If triangle is congruent, then corresponding parts congruent, otherwise known as CPCTC. And once I know that that pair of alternate interior angles, that makes its own zigzag here, then we know that AD is parallel to BC. That's how you do it. That was the plan. Haven't written the proof yet, but that's my plan. So let's get down here and write our proof. I see that AB is parallel to DC. I see that AB is congruent to DC. We've made those marks already. Parallel is the arrows, and congruent are the tick marks. Parallel gave us these angles, 2 and 4. If parallel lines, if has to come earlier, then alternate interior angles are congruent. I know that for sure. If happens earlier, then is happening right now. You've got to use the word alternate interior. Now they're suggesting that we talk about reflexive. That was a third bit of information we needed to talk about. So BD, from the angle we have marked down the reflexive side from B to D, is going to be congruent from the angle that we have congruent down the reflexive side. We're going D to B this time. So that gives an explanation on why we would switch the order. It's still reflexive. But to go in corresponding order, we would go DB for that triangle, but we would go DB for this triangle. We know this is the reason to prove triangles congruent. So I know that my triangle, you can name it any way you want. There's 6 ways to name it. Probably alphabetical is what I'd suggest. A, B, D. Now the second triangle you have to name in the correct corresponding order. It may not be alphabetical, I don't know. So A was the one out here. That corresponds with C, the one way out here. So C is going to go first. B was down the parallel. So to go down the parallel side, I get to D. And then I went down the reflexive side. So I'm going to have to go down the reflexive side to get to B. And again, that reinforces why we say BD and DB. The order was changed. Okay, once you have triangles congruent, then there's 3 other sets of parts that we haven't even talked about yet. We could talk about pair of sides. We could talk about A or C. But what we need to talk about that's going to give us parallel lines would be alternate interior angles. So we know that angle 1 and 3 have to be congruent. The D in the first triangle matches the B in the second triangle. Corresponding parts, 1 and 3. If triangles congruent, then corresponding parts are congruent. You could abbreviate that CPCTC. Now, since we have these 2 angles, oh, I'm sorry, I wrote that wrong. No, I did not write that wrong. My bad, getting all confused. If comes earlier, if is our triangle, then is what we're talking about here. Okay, so what are we going to talk about? Why are these lines parallel? Why are those lines parallel? If alternate interior angles are congruent, then the lines are parallel. Yes, we have alternate interior angles that are congruent. Therefore, the lines that they touch, angle 1 touches this one here, and angle 3 touches this one here. Those are going to be parallel. That is AD and BC. If alternate, you got to use the name correctly, alternate interior angles are congruent, then the lines are parallel. So that's one example. Information from congruent triangles might show us parallel sides. It's possible that information from congruent triangles could show us a midpoint. If we were working in this situation, we might end up proving that this point is the midpoint. That's what you need to prove. Therefore, you need to prove these 2 segments are congruent. You might need to prove the triangle is congruent first. If this is the information for some reason you know, side angle side, you didn't even need to use that. So then we would prove those are congruent by CPCTC, And if a big segment is divided into two congruent parts, then it has a midpoint. You could do that. You could talk about if you have a right angle, then you have perpendicular sides. So it's taking the proof an extra step.